So we've been talking about direct proportion, okay? So that's when things lie in a straight line. Now we're going to talk about what's called inverse proportion. And what you're going to see in coming lessons is 1b that we're about to go through, inverse proportion, is really linked with the graphs we see in 1c and 1d. So, two variables are inversely proportional if multiplying one of them by k results in the other being divided by k. That's one way of defining it. If x and y is inversely proportional, we've got this symbol here. That should be an x. Okay, that symbol there means equal to multiplied by some factor. So that means that symbol means proportional to, or we tend to write it like this as well. So they're all different ways of defining it, where k is a constant. Now, if y is equal to k divided by x, one thing we can do here, right, is multiply both sides by x. Okay, and that would cancel. And we have x times y equals k, where k is some number. Alright, which means every x value times its corresponding y value will always equal some number k. Alright, some number k. So let's get into the problem. We've got the amount of time to mow Tennyson Oval is inversely proportional to the amount of mowers you have. Alright, so what we're saying here, if you have one person, it takes them 60 minutes. Alright, if you have two people, it's going to take them half an hour. Who wants to guess 3 people? 20 minutes, very good. 4 people? 15. And 5 people? 12.5 minutes, very good. Yes, 60 minutes, yep. Cool. Alright, so we've filled in the table. Now what I want to point out here is that 1 times 60 equals 60, okay? X times y equals 60. 2 times 30 is 60. 3 times 20 is 60. Okay, notice how every x value times every y value equals 60. Okay? Because this is true, the variables are inversely proportional. Every x value times its corresponding y value. Alright, so that's that. Fine, fill in the table, done. Part B, hence state the equation of time to mow Tennyson Oval. State the equation. Well, the equation of in inverse proportion is this. Y equals k divided by x. That's the default equation. What is our value of k? 60. Right. So therefore the equation is 60 divided by x. Okay, so that's pretty good. What I think I would like to do though is supplement 1a and 1b with some... Okay, so 7, 5, 7c. Okay, so I'll make this bigger so Alright, so the first thing we might do then is maybe we will graph that function that we just had, 60 divided by x. Okay, so the way we're going to do that is in the main menu. To get to the menu, you press the menu button. Okay, see where my mouse is now? Menu. And we're going to go into graph. Okay, so go down. And to access it, we press the execute button. That means enter, that means select. Okay, execute. I want to use that mode. So we're going into graph. And already it says y equals. That's what that is. y1 equals. And we're going to plot a function here. We're going to plot the function 60 divided by x. Now, whenever we have a fraction as a function, I like to use this button, A, B, C. Okay, that's going to bring up a fraction for you. We're going to put 60 at the top. So I'm going to press the fraction button. 60 at the top. Now this is an old version of the calculator, so yours is going to look a lot nicer than mine does at the moment. 60. And then at the bottom we need our variable, x. Now whenever we want to put x in, we're going to use this button over here. X, theta, t. That's our variable button. X, theta, t. That's how we bring up x. So we have 60 divided by x. Alright, I'll just see if we've got some questions so far. Oh, you're in parametric? Yep, so I'll just change that and I'll show you how to fix that later. Any other issues? Okay, now before we graph it, so if we wanted to bring the graph up straight away, we press enter. But before we graph it, I would like us to change our V window. So we're going to press shift, okay, shift, right here. And this is going to bring up a number of options for you, only one for me, where it says V window. This is probably the most important function when you're graphing, because your V window it's going to sketch a graph, but it's going to sketch it over some Cartesian plane. So here's the Cartesian plane, and the box I've got around it is what we call our V window. It's our virtual window. Okay, this is important. Over here on the far left, we have what we call our x min. That's our minimum value of x, the lowest that x goes. Over here, we have our x max. That's our highest value of x. Our y min and y max. Now, if you can't see your graph, okay, change your V window, zoom out, all right? Now, they do have a couple of standard settings for you. They've got your initial one, your trig one, STD is standard. So I'm going to set it to standard. I'm going to press F3 to set it to standard. And that sets x as minus 10, y as minus 10, okay? So we're going from minus 10 to positive 10, and from minus 10 to positive 10. Okay, so standard, you can put those numbers in if you like, and then we're just going to press execute, and execute again to graph it, okay? So it's bringing up our graph for us. Now, we can't see it very well, okay? We've got our Cartesian plane here, but we can't actually see the graph very well. So what we're going to have to do is zoom out a little bit. So there is a zoom button, but I prefer just to change the V window. So I'm going to go back into my V window by pressing Shift F3, and let's change it. Let's zoom out from minus 50 to positive 50. Okay, let's zoom right out. Minus 50 to 50, and then the same with Y. Okay, and we can start to see a bit better there. Here's what the graph of it looks like. Okay, so we've got one equation there. Let me show you another thing that we can do. Alright, so let's press the exit button. That's going to take us back to this mode where we can put more functions. And we can have more than one function in our graph. So here we have, what's it called again? An inverse function. Now we're going to sketch a linear function. So let's just put any one in. Let's put y equals 3x plus 2. Okay, 3x plus 2. Okay, and we'll keep the V window as it was. And so we press enter, and it's going to sketch both functions on the Cartesian plane. Now there's a number of things we can determine here. So just very, very quickly, in GSolve, okay, root, so I'll just say that again. GSolve corresponds with F5. We've got root, that's where it crosses the x-axis. Max and min we won't deal with yet. So just hold up 1 second, just stand there for 1 more second. We've got y-intercept, which is where it crosses the y-axis. Intersection, where the two functions intersect. So you can calculate that. I can press intersection, it's going to tell me they intersect there. I can press the cross arrow, they intersect there as well. Alright, better stop. So,